More
but you won't
coffee in
be.
my mug.
I
So
won't.
that
We're not
works.
going to be live. Sorry, I'm just going to start from OBS. So yeah.
Yeah, yeah, yeah.
Okay. Put that on. Boom. Okay. Here we go.
Okay.
We're live.
Yay! I think yay. Maybe yay. Possible yay.
Everyone says that we are on um, the wrong sides of the
Wrong side.
screen. Yeah, yeah, yeah,
That's hilarious.
yeah. Now we're not streaming out to Twitch. So
No.
so what's going on here is Pamela is traveling and so doesn't have the studio set up, and so I'm handling uh, the live stream. So people need to let me know if our audio levels are equivalent.
Yeah. So I'm in a hotel room, and the internet here is sufficient for one Zoom to be open. It is insufficient for both Zoom to be open and streaming software to be open.
Yeah.
And I had the stupidest technological fail. So based on our discussion last week and being able to do zero interest for 12 months, look at the new toy I got. Can you see the new toy?
I can't. Hold on. Oh, wow. Yes. What a
Yeah.
great
So I
toy.
got one.
Yes.
I got one.
Yeah.
And they work as a webcam, but
Yes.
not on a MacBook Pro. I plugged
They
it into my
do.
MacBook Pro, and it may be the age of mine.
Nope.
And
Nope.
a
It's the
message came up and
cable.
said, US, oh, it's the
It's the
cable?
cable. So if you're not using the one that came with the camera, it's not going to work. It has to be the one that came with the camera. I'll bet you're using just a general USB cable that you have kicking around.
Yes, I
Yes,
was.
that's it. That's the
All
answer.
right.
I had the same problems.
Yeah,
It
I got
works.
a very angry message that came up and said USB device disabled, drawing too much power.
Right. So use the
And
one.
and
Yeah, it comes a little cable. Yeah, that thing is an absolute game changer for me. It has taken my entire traveling studio and compressed
uh,
into that little that little thing. That's it. I
that
don't
is
I don't take
amazing.
anything else. I don't take a professional mic. I don't take a big camera. I don't take lighting. I don't take any stands. I don't take anything. I just take that. And the
I
audio
do
is
have a tripod with me.
yeah, whatever. I mean, if you want. I do have a selfie stick that has a
Yeah.
flat bottom on it, and so I can actually take the thing and set it up and then be able to talk into it. So that's the only thing that I use.
Yeah, I was trying really hard. So I'm currently in Orlando, Florida. I used the Podfest podcasting convention where good friend George Fropp got inducted into the Podcast Academy Hall of Fame the other night. I used it as I shall go watch Firefly launch. I shall go watch New Glenn launch. Failed.
Yeah.
Um, And I have a bunch of meetings scheduled this week with people out here on the Space Coast. And I'm going to spend one day at Disney because this is me. But because Firefly Aerospace and iSpace, they launched on the same Falcon 9, it was a night launch, and New Glenn was a night launch. I was like, I'm going to want a tripod
Yeah.
and a 400 millimeter lens.
Yeah.
And it turned out that for the photos I wanted to take, no single exposure time could work.
Right.
So I'm going to be spending hours and hours and hours trying to process things together. And it's probably not going to work because of wind.
Yeah.
But I tried, and I have now seen a Falcon 9 launch. I've now seen the night launch. I can now say anyone who can do night photography of a launch is an amazing, amazing human who has mad skills.
Right, because you have to change the exposure dynamically as the event is happening, but still capture like a long exposure that gives you all of the bits and pieces of it. Yeah, it's similar to the pros who capture good images of eclipses, because all of the exposure settings leading up to the eclipse are worthless at the moment of the eclipse. And so
exactly.
Yeah,
I have a truly terrible video of the launch on Instagram that was taken with this. And the reason it is terrible is mostly I was just learning what I was doing. And the Pocket 3 does not have a 400 millimeter lens on it.
No. It's got a very wide angle lens. Yeah. But yeah, I mean, the quality of the camera is almost as good as the quality of the camera that I'm using as my webcam. This is a $5,000 camera, while the camera on the Pocket is it's a $600 camera, but the quality is really good. I think even in low light, that thing is phenomenal. So yeah, it's the DJI Pocket 2, right?
3. I got the 3.
Yeah, the DJI Pocket 3. Yeah. It is all in one. Like now it's my recommendation. Like if anybody needs to do any traveling stuff, and so I'm planning on getting like a second one so I can just do interviews. I'm just going to set up 2 of them, give everybody the Osmo. It's the Osmo. Yeah, the DJI Osmo. I'm going to give people and it comes with one lav mic, and I've got the full lav mic kit that comes with DJI. Set up 2 of them, but boom, you're done. Like that's your mobile studio. 2 selfie sticks. Yeah, that's the lav mic, and Anton, my editor, is able to just do wonders with the thing. So it's such a load off, because whenever I have to plan stuff, I'm like, oh no, it's just going to be like all this gear, and no, you just travel in a simple carry-on with one little bag and you're set. So yeah, it's a whole new world.
And thank you for telling me about the cable. I would not have solved that on my own.
Yes, yeah. Let me know if that solves the problem for you. Okay, well, I guess we should do our jobs.
Probably. Yes. Okay. All right. I am pressing record on my audio.
Okay.
It is recording.
I am pressing
record. Wow, those levels are low. Rich, we love you, and I am sorry about how low that audio is, but it's recording fine, so we should be good.
Astronomy Cast, episode 741, Technosignatures. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know. Astronomy Cast, episode 741, Technosignatures. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how are you doing? And where are you?
I am in a hotel room in Orlando, Florida. I got to see the Firefly Aerospace and iSpace landers, hopeful landers, take off on a Falcon 9 last week. I had planned to go see the New Glenn launch, but I had a moment of fail. They sent out an email saying that they weren't going to have a media site set up, and it was cold and it was gross. And I was like, oh, it's not going to actually launch tonight. So I decided to stay warm, wrapped up in a blanket, and it did actually launch.
Right. And at some point you're hearing the building shaking. You're like, oh no. Right. There it goes.
But I have to say that as a single female traveling alone, I would not have been comfortable trying to find someplace to watch a 1 a.m. launch in an area I'm not familiar with. So I made the right choice. But yeah, it's been amazing, and I'm gonna go meet with a bunch of collaborators and folks out on the Space Coast this week.
Oh, great.
And Blue Origin has a huge facility that was not here at all when you and I were out here for the OSIRIS-REx launch a gazillion years ago. And I just want to take photos of how big
Oh, that's amazing.
and branded with feathers their
Yeah.
facility is.
Yeah, and like hopefully you can get more. Like they did have
Yeah.
a facility, but we just drove past it in the bus and we couldn't see what was
Right.
going on. But hopefully you can actually get in behind the scenes and do some tours. That would be amazing.
Yeah.
All right, as
I'm
humanity
hoping.
as humanity develops more advanced technology, we're having a larger effect on our environment. The more we do, the more we could be detectable. And this gives us ideas on how we could detect other civilizations, even if they don't realize we're watching. And we will talk about it in a second, but it's time for a break. And we're back. So there's a document that is rolling around out there that I have really been wanting to try and get my hands on about this idea of technosignatures. So NASA now does this like a conference once a year, every couple of years, where all of the top SETI technosignature researchers come together and brainstorm ideas. And it's, you know, Jason Wright, David Kipping, and Seth Shostak,
David
and all Grinspoon. Yeah, like all of these luminaries in the SETI, METI, WETI space, as well as you know, more traditional exoplanetary researchers. And apparently there's a list of 39 technosignatures, 39 brainstormed ideas so far of different ways that an advanced civilization could be giving off some signal of its existence. And we've tackled the sort of, they're sending a message at us with radio waves or in invisible light or something, but that's just like one or two of those potential technosignatures. When you consider this sort of broader idea of all of the different ways that a civilization could leak its existence, it's kind of mind-blowing. And some of the ideas are extremely cool and sort of very creative and out of the box ways of thinking about this. So like, what is a technosignature?
It is a signature, to lame definition is lame, that says there is a technology here that is influencing the light being emitted, the spectrum of absorption lines in light that is being reflected or absorbed, or otherwise a phenomena that can only be explained through leaked or influenced signatures created by technology, which is basically a fancy way of saying that if you have a Dyson sphere, you're going to have excess IR radiation. If you have a whole lot of pollution from chemistry, industry processes, you're going to have absorption lines that can only be explained by technology. And these are all unintended consequences of a civilization that can be detected at distance.
Yeah. And the list goes on, and from, you know, warp drive signatures as they're moving, us being caught in the stray beam of a powerful radio pulse while a civilization is trying to communicate with another, gravitational waves being used to communicate through space. As you said, you know, some of the unintended ones, like they're in the midst of having a nuclear war and we're detecting the gamma radiation happening on the surface of their planet as they're bombing one another, industrial pollution, the list goes on. And what I love about this is that many of these are unambiguous. So while biosignatures are very ambiguous, you know, we still argue about whether or not there's phosphine in the atmosphere of Venus and whether or not even phosphine is a biosignature. or carbon dioxide or methane or carbon monoxide or dimethyl sulfate, and all these ideas, you see a partially completed Dyson sphere or a transiting exoplanet that is in the shape of a triangle, there's
Yeah.
something weird going on here that is not what the universe would naturally cook up. So can you give me some examples of indirect technosignatures?
Indirect
Yeah, so
technosignature.
the direct are the ones where they're intending us, letting them know that they're
Okay.
there.
Yeah.
The
Sorry.
indirect are the ones where we're just being, we're just being curious and we're snooping on their existence.
So my favorite, and I already hinted at it, is the infrared excess from systems that have massive structures in them. These are the Dyson spheres, the rings like Larry Niven imagined with his Ring World books. And there are a number of catalogs out there of all the detailed photometry of stars across many different wavelengths. And people are actively looking to see, can we find worlds with infrared excess, and then following up to rule out things like dust
Mm-hmm.
and uh, all the normal stuff that might be able to cause infrared signatures like that. And there's a whole list of them being followed up so far. And of course, none of them have yet proven themselves
Yeah.
to beyond a shadow of a doubt be a Dyson sphere. But Cabby Star gave us one heck of a wild ride more than a decade ago. The Planet Hunters project, the citizen science project, to go through the Kepler data and look at the light curves of stars to see if there were planets that had otherwise just not been noticed by the software. And one of the stars that got flagged and was then sent to Tabitha, and I'm going to say her last name wrong. I am so sorry. She said it to me multiple times and it never sticks. Tabitha Boyugin.
Boyajin.
Do you know how to? Thank you. He knows how to say it. Tabitha Boyagin, she, as a graduate student, took on this star and was trying to figure it out, and ended up doing a crowdfunding campaign to afford her telescope time. And ultimately, it turned out to be like your normal swarm of naturally occurring objects in that solar system. But it really looked like it could be
Yeah.
something under construction. It was amazing, and showed us that we can get super excited about the possibility of life around another star, and the world does not get excited with us. So I have a feeling that when we do finally find life, no one's going to pay attention to us.
Yeah, and we know that there are, this can work at various scales. At the
Yeah.
smallest scale, we are, as human beings, we are producing excess waste heat. We've started
Yeah.
to increase the temperature on the planet through global warming, emissions, but just direct, even if we make the most efficient, energy neutral sort of technological civilization, we will still produce waste heat, and that waste
Yes.
heat will increase over time. And people have done calculations that within 1,000 years or something, we will start cooking the planet purely by the waste heat from us having an economy. Like, it's all green energy, but yet it's still producing so much waste. And so you can imagine at
Yeah.
a planetary level, you're going to see the waste heat coming from the planet, but you can also imagine at a like at a stellar level, as you said, if you're starting to enclose your star in this collection of satellites, you're starting to shift from visible light into the infrared in a way that's very weird and bizarre. But you can take that
Yeah.
even to the next level, where you have enclosed every single star in your entire galaxy, and you're creating a galaxy that is an infrared signature. And in fact, astronomers
It's
have
wild.
have done surveys for these strange point-like objects that are putting out too much in the infrared and not in other wavelengths of radiation, and identified, like, I think 6 candidates later, last year.
There were 6 new ones. The total list is around 30 objects.
Yeah.
And what's cool is they're using machine learning algorithms, and machine learning is where you train something to identify and annotate sources. It's not generative, it's not large language models. Machine learning is annotating things so that human beings don't have to go through these catalogs. And with every new listing coming out of Gaia, it's going through and having more sources get identified by these algorithms. And eventually it's either going to hit the point of awkward that we aren't finding any, or we're going to find something to follow up on. I hadn't known about the galaxy idea though, and now I'm like, oh, so when we find these dark matter dominated galaxies, we need to give them a triple look to make sure that it isn't just like an overly zealous Dyson sphere creating civilization.
Yeah.
And that's not something I'd thought of before.
Yeah, well, and the other thing that's kind of interesting is there's all these amazing ideas about moving stars. This idea of Shkadov thrusters, where you could, you know, you have this giant mirror that you build that is on one side of the star, and then the radiation from the star pushes the mirror away from the star, but then the gravity from the mirror pulls at the star, and the star actually then pulls itself around in whatever direction you orient the mirror. And you can move incredibly quickly. You can end up moving like to 25% the speed of light. You can be moving your star at 25% the speed of light after 1 million years of using this thruster. And so you can, over reasonable amounts of time, definitely less than 1 billion years, you can completely rearrange all of the stars in your galaxy to a more pleasing shape. And so you can look out into the universe and you can look for galaxies that are like, you know, spiral, 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 dodecahedron. Wait, what? You know, where someone has gone and they're like, what is the best structure for a galaxy? Man. And they can have moved that entire galaxy. And, you know, I've seen some really cool simulations where you end up with like a supermassive black hole with like a billion times the mass of the sun that's surrounded by a collection of supermassive black holes, each of which has 10 million times the mass of the sun, and then each of those is surrounded by black holes, and then those are surrounded by stars, and then those, and you could have 1 million terrestrial planets in one system where you could communicate within a couple of light days to every single planet within your entire 1 million planet system. And it's like, obviously it boggles the imagination, but we just look for weird things that people have constructed out in the universe. All right, we're going to continue having this conversation, but it's time for another break. And we're back. So that's one example where we're sort of seeing them at a really incredible level. But I think another thing that's really important to talk about is just like we could see transits of things that give off a strange signature.
Yes, and this can take many different forms. And we're getting to the point that we're starting to be able, we think, to detect moons within transits where what's happening is when you have a round object pass in front of we're going to pretend my iPad is round and looking to see what I'm advertising. Okay. As that round object passes in front, its roundness causes the light to go down a little bit, down, flat. And then as it comes out the other side, it has a characteristic, the way it goes down flat and the way it goes up, that it can be caused in different ways, but the simplest way to cause it is by having a round object pass in front of the star. Now, if instead you have that triangle that you had mentioned earlier, as it goes in, especially if you have something, I have nothing triangle shaped in my area. I'm going to grab apparently my trackpad. So if you imagine, we're going to call this a triangle. As it passes in front, that's now going to cause a different shape of dip. And if it has the flat edge going in front first, that is a wildly different shape. Mm-hmm. So by how the shape passes in front of the star, you're going to end up with different kinds of shapes to how it gets down to that flat point at the bottom of the eclipse. And we only know how to explain round things and things that would be like two round things next to each other.
Right.
We can explain that and
Right.
nothing else.
Yeah.
And where you can't explain it, that's where you start blaming civilizations that built really big stuff.
Yeah. And someone did the math and found that's the most efficient way to communicate your existence to the universe. That attempting to broadcast with radio waves or attempting to send a tight beam radio or laser at some other star system on a regular basis uses up a lot of energy on an ongoing
Yeah.
basis. But if you could build a giant mylar sheet or cloud of satellites and organize them into a specific shape, and then you just let orbital momentum keep them going around your star system for literally ever. Um,
Yeah.
and then you are now broadcasting to the entire universe, civilization here, right? Whether that's a good idea or a bad idea, who knows? But you can imagine some civilization making that investment and saying, let's put out our for sale sign or put out our open to chat sign to the universe, and then you just put up this thing and it just goes around, and every time someone looks at the star system, where they're lined up, they see this triangle. They're like, okay,
And there's
there are people there.
subtleties in this that are the things that I really am fascinated about. So we know we're eventually going to need to have communication satellites that allow us to talk to anyone, anything that we want to communicate with on Mars when Mars is on the far side of the sun with us. And so the way to do this is to start putting equally spaced spacecraft around the orbit so that they can beam information to each other to get it to us. Now, imagine having massive space stations evenly spaced in their orbits where they're all in the same orbit, and you keep seeing dip in light, dip in light. And you can see how fast something's moving in its orbit by how long it takes it to pass in front of the disk of that star. But then it keeps happening such that you can't explain the dips and the crossing time by a single object. Once you start figuring out, oh, that's 5 exactly evenly spaced objects. That's not something
Yeah.
that the universe put there on its own. And that's where it starts to get Isaac Asimov futures
Right.
written in eclipses.
And kind of related to that, people have proposed that when planets are transiting, and especially when you have multiple planets transiting at the same time, it's the perfect opportunity to watch that star system. Think about the TRAPPIST-1 system. So the planets are all lined up from our perspective, and so we see them as they pass in front of the star. But if we watch and see 2 of the planets passing in front of the star at the same time, then one planet might be attempting to communicate with the other planet, and they're going to send a radio pulse or a laser pulse at the other planet, and we could get caught in the crossfire. So we would detect the leaked signals when one planet was communicating with the other planet in this direct way. And so astronomers have proposed that we direct our radio telescopes at TRAPPIST in those moments where you've got those alignments in front of the star. All right, we're going to talk about some more ideas, but it's time for another break. And we're back. So I want to talk about some of the stuff that we're doing to our atmosphere that perhaps other civilizations would be able to detect, and how they might be able to do it.
Well, there's things that don't belong in our atmosphere that luckily are decreasing in amount, like chlorofluorocarbons. Those are complex molecules. Those of you who grew up in the 80s remember hairspray suddenly went from being the stuff that you could use to create flamethrowers if you were an appropriately minded middle schooler, to being like these very boring squirt bottles. And the reason that all of our Aquanet suddenly changed was the decision to try and prevent more chlorofluorocarbons from getting into our atmosphere unless we absolutely had to have them. There was similar attempts to change out air conditioning
Mm.
cooling fluids, and that's an ongoing process as houses get their systems changed, as old cars get their systems changed. But there's going to be a large swath of time in Earth's history where our atmosphere had all these chlorofluorocarbons that can be, with high enough resolution spectroscopy, detected in how the sun's light gets changed as it passes through the Earth's atmosphere, and then detected by whoever is out on just the correct line through the sky.
And there are papers out there right now that where people have done the calculations based on how much time it would take for James Webb to be able to detect chlorofluorocarbons in the atmosphere of an exoplanet, say at the TRAPPIST-1 system. And it's not a lot. Like, it is within the
No.
capability of James Webb, and it is absolutely within the capability of the next generation telescopes like the Habitable Worlds Observatory and
Yeah.
so on, to be able to make those kinds of detections out to hundreds of light years away. It's such a strong chemical in the atmosphere, gives off a very unique signal, and there is no natural way that you could produce that chemical. It has to be a technosignature. But
And
you.
there's a whole suite of different molecules
Mhm.
that, as far as we know, can't be produced another way. Now, as you pointed out, people periodically try and come up with ways to explain molecules that we believe are related to life in one way or another and blame geology. But things like chlorofluorocarbons, we just can't get there from here.
Yep. And so we are, and over time, as we develop new chemicals and we put them into our atmosphere for good or for evil, those will be detectable by other civilizations. Or like, oh, I remember the time when we thought it was a good idea to pump that chemical into the atmosphere to try and prevent climate change, right?
Yeah.
And we
Yeah.
can watch them doing it. But then the other thing is that we are putting out electromagnetic radiation, and there's this
Yes.
classic, was it Contact?
Yes.
Contact, where the
Hmm.
movie starts with this sort of increasing bubble of radio waves that are moving away from the Earth, where you get different television shows at different times, because we've been broadcasting radio waves out into the universe for 100 years.
And it's not coherent enough that unless they know exactly what they're looking for as they try and deconvolve all the signals from all the different stations, they're not going to be watching I Love Lucy. They might be watching the first Olympic broadcast because there really wasn't anything it was competing with. But we're sending out radio signals that can't be explained naturally, and it's just a mess of changes across all these different wavelengths that basically screams something here is using this technology. And over time we're going to probably see the system change, where we're already starting to realize that if we want to get much higher bandwidth transmissions between Earth and Mars, I'm just going to keep using Mars as an example, we're going to want to start using laser
Mm-hmm.
transmissions. And that is much more point to point. But to use your TRAPPIST example, when those two worlds are lined up just right, that beam broadens, and what isn't eclipsed by the planet you're transmitting to is going to go out to potentially be observed by other places in our galaxy, probably not beyond, just because resolution is a thing. But we're polluters in all sorts of different
Right.
ways, and that's how we're going to get found.
Yes. And like right now, we couldn't detect ourselves. We don't have the
No.
telescopes to be able to detect our brightest radio emissions, the ones that are being sent out in all directions. But we have a telescope that's coming, the Square Kilometer Array,
Yeah.
which will be operational, early 2030s. And that, someone had told me that it would be capable of detecting the air traffic control system from Earth from 100 light years away.
Which is just amazing to
Amazing.
imagine.
Yeah, yeah. So, it could be your cell phone provider on Mars. Right. could pick up your cell signal while you're talking to someone from Mars. It's going to be kind of amazing. And we are not by any stretch of the imagination an advanced civilization.
No,
You can
we're not.
imagine what the one that the civilization that's been around for 10 million years and has built a radio telescope the size of their entire star system, what they
Yeah.
would be capable of detecting through these radio emissions. Um, uh, so that's all great. And then, there's some really interesting science fiction ideas where, we could imagine like warp drives.
Yes. And high energy particles that get created in all of these different kinds of reactors. We're forever trying to figure out the origins of this or that cosmic ray, and a lot of them we can't, we never will. But you can imagine that you start to detect basically a line of places where these particles are emanating from, and that could be essentially your signature of some sort of a nuclear or matter antimatter or
Mm-hmm.
otherwise generating wild high energy particles spaceship going by, emitting these particles as it goes. And as we get more and more into multi-messenger astronomy, where we're combining our ability to look at things uh, in all the colors of light, looking at things through particles, and ultimately looking at things also in their gravitational signatures, we're not going to be detecting the gravitational signatures of a normal spacecraft, but the particles and the light are things that you can imagine. String of gamma rays, infrared excess. Oh, that is a matter antimatter drive over there.
Yeah. Did you see the paper where they were talking about how we could use LIGO to detect a warp drive failure?
No, that
Yeah.
one I missed. Tell me
Yeah.
more.
Yeah. So just that when a warp drive is operating, it's going to be essentially moving space time, and then that's going to be creating
Yeah.
gravitational wave ripples as this thing goes past. But the thing that would be the largest broadcast of gravitational waves would be when the warp drive bubble fails and collapses, and that you would then get this shock wave of gravitational waves that would emanate from wherever the warp drive failed, and that would be the clearest, strongest signal that we could receive that someone is out there using a warp drive is when they all
And
died.
and that's at a resolution LIGO can see?
I mean, it depends on the distance, right? So
Okay.
yeah, it just
What
depends on how
what
far away it is. Like LIGO is amazing. Like you can detect colliding black holes hundreds of millions of light years away. I'm not sure how far away it could detect a warp drive moving through
well,
the Milky Way.
and and it's the frequency issues. So as we start looking for smaller compact objects that are crashing into each other, we're going to start needing the resolutions that LISA's going to give us. And as we figure out, oh, this is the signature of an exploding warp coil. That's sad. Uh, what frequency band is it going to be in? Is this the next wow signature that we're going to
Right.
find that actually does turn out to be something cool?
Yeah, that's pretty
Uh,
cool.
yeah, the pollution that causes astronomers to curse and blame whatever the next generation version of pigeon poop in their detector is could very well end up being a civilization, and that's just amazing to
Yeah,
think
yeah,
about.
awesome. So, I mean, this is just like we're literally just scratching the surface of some of the amazing ideas that people have proposed,
Yeah,
and I mentioned at the beginning of this episode that there's this list, and I really want to get my hands on this list
yeah.
because then I can provide this kind of comprehensive breakdown of all of the ideas. But I hope that gives people. So anytime you do anything, ask yourself, could we find aliens doing that thing? What signals are we giving off as we just run about our daily lives? Yeah, it's very cool. Awesome. Well, thanks, Pamela.
Thank you, Fraser. And thank you to all the people out there who support us via Patreon. We would not be here without you. And we're in the process of cleaning up our website, and you're allowing Aviva and Ali and Rich to really allow us to get things cleaned up into a new age. This week, I would like to thank Alan Gross, Alex Cohen, Andrew Stevenson, Andy Moore, Bebop Apocalypse, Bill Smith, Brett Mormon, Cami Rassian, Daniel Loosely, Danny McGlinchley, David Gates, Disastrina, Dr. Whoa, Ed Elliott Walker, Father Prax, Frank Stewart, Gerhard Schweitzer, Gordon Dewis, Gregory Singleton, Jarvis Earl, Jeff Collins, Jeff Hunamorder, Jeff Wilson, John Drake, Keith Moray, Kellyanne and David Parker, Kimberly Rake, Christian Golding, Laura Kettleson, Lee Harborn, Mark Phillips, Matthew Horstman, Matthias Hayden, Michael Perchata, Mike Dogg, Nyla, Noah Albertson, Red Bar is watching, Shersum, Semyon Torfason, Siggi Kemmler, Stephen Veit, the Big Squish Squash, the Lonely Sand Person, Travis C. Porca. Thank you, all of you, so very much. You make great things happen. Thank you.
Thanks, everyone, and we'll see you next week.
Bye-bye. And then they
saved.
All right.
7:41.
Yep. This computer doesn't have shortcuts to all the files on it. And next week, folks, you're gonna get to witness me trying to do first time on new computer. So Fraser has cost me a lot of money lately in very good ways. It's true. It really is true. So in addition to convincing me that investing in the Pocket 3 was the correct thing to do, which it was.
The Osmo.
No
Osmo.
regrets.
Osmo.
Yeah, Osmo. Sorry, it says Pocket 3 on it. So yeah, it's the DJI
Osmo.
Yeah.
Let's see.
Pocket
DJI
3.
Osmo Pocket 3. Okay, yeah, the Osmo Pocket 3. Yep. Okay.
So in addition to convincing me that that was the thing I needed if I'm going to start getting myself back out into the world again, which is what I'm trying to do. If you're looking for a conference speaker, please invite me. We were also, Ali and I, having an existential crisis over the 25% tariffs that are being threatened on all Chinese goods, knowing that Apple products happen to come from China. I have a pair of 2019 computers, my laptop and my desktop, and she has a 2020 computer that was not as good as we thought it would be. And we weren't going to make it 4 years.
Right.
So we both got a new Mac Mini. So when I get home, I'm going to be setting up that new Mac Mini for recording with, starting with our next episode.
Yeah. Yeah. I mean, there's definitely, I find setting up Macs to be able to do all the work is a bit of a pain, but once you're there, then it's great. You know, all of your scripts running and all of that. Yeah. I'm using the Mac. It's an astonishing piece of technology. And I just got the base level. Yeah. I think you went with more of a Pro with a little bit more memory, but the base one is $599, and it is the best computing bang for your buck that you can really buy right now.
Yeah, we upgraded the memory on it, and I want to say we got one up from the baseline processor, but we also have a nonprofit discount, which allowed us to stretch money much further than we could have otherwise.
Yeah, that's good.
So the thing that got me, though, is the cost of getting a Thunderbolt dock that I can plug all my peripherals into. It was just like, it's bigger than the Mac.
Yes.
And cost almost as much. It felt like it did not. It just felt that way.
They're like $400 for the Thunderbolt dock. Yeah, it's not a cheap thing. But then it can just sit there and you can plug in your laptop into it. You can plug in any computer into it.
Yeah.
And you just plug one plug, and then everything is now all the peripherals, and it goes at thunderbolt speeds. So it's kind of a
Yeah.
necessary investment into the future. I've got one too, but unfortunately my the adapter is making a whiny sound, so I have to get it swapped out.
Oh.
So I'm having to deal with
Oh
their
no.
technical support. Yeah, yeah. Um, so what do we want to talk about? I see one question from Lionel about how big would a space station need to be before we could detect the dip, and I guess it just depends on the size of our telescope.
The size of a moon, we know we can detect. So, and it depends on its distance from the star. So the closer to the star, the smaller the object can be when we find it.
Yeah.
Um, I don't know the actual numbers, and I'm sure it's going to change abruptly once LSST gets on the scene.
Yep.
Um, yeah, I don't know right now.
Okay. Let me see then. I guess we're going to talk about things we're watching and doing. So, or this is going to turn into a rant if somebody triggers me somehow.
Yeah, or
so,
me. It
oh,
could be me.
yeah,
It's
it's true. It's
usually you.
true. So the thing that I mentioned, was talking to you before the show. You finally caught up on Arcana.
Yes, yes.
How do you like it?
It is a beautiful show that has fully realized characters that can be good, can be bad, can be gray. And we don't get to see people that aren't only one thing nearly often enough. And the artwork is
Yeah,
so
it's so great.
stunningly beautiful. Like I went to go see the new Lord of the Rings universe anime style movie that came out, and its animation was not good.
Mm.
I'm just going to leave it at that. And to go from feature film that brought me sadness to watching something where it's just like the facial features and how even the eyes are responding in the moment.
Yep.
It was amazing. And there were so many little details in it. Yeah, I'm just gonna sit here and
Yeah.
say go watch it.
Yeah,
It
absolutely.
was
Go watch it.
good.
It's on.
Listen to Fraser.
Yeah, it's on Netflix, and
Yeah.
you know, the second season. You finished the second season as well.
Yeah. Yeah.
It felt a little rushed, where there's a lot of situations where we were looking at stuff going like, who is this person and what's this about? So
Right.
they clearly had to, like, they only were given a second season, which is a tragedy because they should have been given 3 seasons to really tell their
Mm-hmm.
story, I think. But apparently
Yeah.
they're going to do some spin-offs. There's going to be other stories in this universe. Like, it is
Yeah.
I think, one of the best things that has come out of Netflix in their entire run. Very cool. And it's weird that it's connected to a video game, League of Legends, that,
Well,
right?
it's connected to an arena style video game.
Yeah.
Because I was like, oh, this is so good. I now want to go play the video game. And I was like, wait, I
Nope.
can't explore storylines.
Yeah.
I mean, I was so confused.
Yeah, it's a MOBA. It's like Dota 2. So it's it's a wildly popular game, but
Yeah.
if it's not your style, it's not your style. So
Right.
the thing that I've been watching, we just finished binging, is The Legend of Vox Machina, which is the animated version of the Dungeons and Dragons campaign by Critical Role, and it's great. It's so good. So for those of you who don't know, Critical Role is a D&D campaign by a bunch of voice actors, and they started streaming on Twitch about 9 years ago, and so they do a great job of doing the voices of their characters, but they also play legit D&D, and the Dungeon Master is phenomenal. And they were sort of telling this story over multiple seasons, and they had built up enough of a following on Twitch and so on that people wanted them to do some kind of actual version of what they did. And so they kickstarted a animated episode of their campaign, and they needed to raise like $750,000 or something to be able to do that, and they ended up raising like $4.5 million, which was enough to do the entire season. And so then they went and got the whole season animated, and they provided all of the voices, and there was no big studio getting in their way to do this. And it was so good that then Amazon Prime ordered a second season, and then ordered a third season. Now they've ordered a fourth season, and it is like it has no right being as good as it is. The characters are really well done. The animation is top notch. The adherence to the original Critical Role campaign is well done, but also told in a way. The mood, the writing, everything of it is top notch, and it was like one of these things where I had on this list, and I'm like, oh god, it's like a D&D campaign. Like, what's it? Fine, I'll watch this. And then I watched it. I'm like, oh my god, this is so good. And now I'm like going back and discovering the original. I always had seen Critical Role show up. I'm like, oh, 6 hours of people playing Dungeons and Dragons.
Yeah.
I don't have time to watch
Yeah.
that, right? And now I'm like, okay, maybe I want to watch that. And so I think it's been so good. Yeah. So if you're looking for something that is low stakes but also really terrific, I highly recommend this show.
And if you're looking for something that is fluffy, low stakes, and fewer hours, I just finished watching Skeleton Crew,
Mm.
and it is truly children's television. But I really enjoyed it. It had the heart and the fun of an 80s teenage TV show. So, like, it would fit comfortably on the shelf with Stand By Me and Goonies and The Last Starfighter and all of those shows that we watched when we were really young. And the only real complaint I had was the characters are going through hell and back, and they stayed clean the entire time. But maybe that's just like future textiles or something. I don't know.
We couldn't stomach more than half an
Really?
episode. Yeah, it was just
Oh no.
yeah,
It was
yeah.
too fluffy.
Two for children. Yeah. Yeah, we watched
Okay.
my wife and I watch it, and we were both just like, nope, nope, not for us, not the target audience. And so we stopped watching. We watched the first episode and then just noped out. And when you compare that to other stuff that's been done in the Star Wars universe, like Andor.
Yeah.
Like Andor is the
Andor is
polar
amazing.
opposite of
Yeah.
Skeleton Crew. It is very dark, very well written, very
Yes.
adult
Yes.
perspective with deep, deep themes that are addressed, and it is top notch. The other show that we've been watching is Silo. They just wrapped up season 2 of Silo.
That's on my list.
Oh,
That
it's
and
so
Severance.
good. Yeah, Severance is fine. Severance gives me kind of a Lost vibe, and that it's a very bad vibe. So,
Okay.
so Severance is fine. I know a lot of people like really like it. I'm like, meh, it's okay. We'll see. Like it's weird for weirdness' sake, and it has
It's an interesting idea, and I do not understand it. And so I didn't give it a Lost vibe. I gave it more of a Twin Peaks vibe.
Yeah, it also has a kind of a Portal vibe. So if you like enjoy
Yes.
the universe in Portal, where things, people are doing tests and things are weird, like it has very much a vibe like that. But yeah, I don't love it and really look forward to it in the way that we like we saw there's a new season of Severance. Like, oh, Severance is back. Okay. While
Yeah.
Silo, we're like, okay, when's the next? And we've been gripped every time the episode ends. We're like, oh, come back. Do another episode right now. So
So
yeah.
I haven't started Silo yet. So I will.
And now you
I
got 2
will go
seasons.
do that.
Yeah, it's top notch.
Yeah.
It's really great. It has a very Fallout feel to it.
Okay.
Without the silliness
That's what I've heard.
that Fallout has.
Yes.
Right. Fallout is
that
very
was so
silly.
silly.
Yeah, Fallout is silly and violent. Well, this is
Yes.
very much about the culture of being trapped in a bunker for generations,
Okay.
or what it would be like to be in a generation ship. It's really well done.
Okay.
Gordon Dewis is asking if we listen to any of the official podcasts that accompany the shows. No, I don't.
I listened to the podcast that accompanied Foundation, and it was really good. I need to watch the second season of Foundation. What I really appreciated about that is
Third.
Geez, I'm behind. With Foundation, there's no way you can just like follow the book to tell the story. So it's much more of an inspired by the books.
Yeah.
And so hearing the host talk to the writers, talk to the actors about how they got the inspiration, how they did the translation, it just added a whole layer to it that I deeply, deeply appreciated.
Yeah. The
Um, wow,
podcast Behind the Expanse was pretty good. Was it Ty and the other guy?
I don't know.
Yeah, it's where one of the actors is with one of the writers for the books, and they're interviewing other people on the show and stuff, and it's really good. Uh,
Have you
but
read
in
the new
general,
book?
I don't do that.
Have you read the new book from the completely new series that the authors of The Expanse, who go by J.A. Corey, just released?
No.
I downloaded it last night. It's on my list of things to escape reality into. Um,
Yeah.
so yeah, I'll let you know how that is come Monday.
And then I have my favorite movie of the year, which was it's called Perfect Days, and it is
Okay.
about this guy in Tokyo who cleans toilets and has this very regimented routine that he goes about every day, and it just transports me back to the time that we spent in Tokyo and just cleaning toilets. But no, and it's just, it's beautiful, and it is quiet and is contemplative, but it's
Oh,
also deep and meaningful, and and yeah, it's just the perfect movie for me, and I loved it.
that's
So yeah,
awesome.
Perfect Days. If you want to, I'm not sure where it is. Like in Canada, it's on Crave, but I'm sure where it's at in the U.S.
I'll have to
Um,
look.
and then I am reading. What is it? This is a recommendation from you. A Short Journey to an Angry Planet.
Yes, by Becky Chambers.
Yes. Yeah. And
Yeah, it's her stuff is so it's just good.
like the world building is off the charts. Her
Yeah,
ability to
yeah,
create this populated universe of really interesting characters and of interesting alien species
yes.
who are interacting in a what felt like a very realistic way. Like
Hmm.
like when you typically have alien species that are interacting with each other, it's always feels like it's very much like there's these giant cultural differences and they don't understand each other, and there are these people that are very militaristic and warlike, and those
Hmm.
people, and the Vulcans,
No.
and they're very logical and blah blah blah. But she says no, like everyone's going to get over all that, and they're going to learn to interact in ways where they understand each other's culture and they know how they're different, but they also are kind of, are into each other, and
Yeah.
there's this like it's hard to explain, but it's like they appreciate each other's cultures in a way where they can then work as the crew of a starship or
Yes.
stuff like that. And I really enjoy it, where it's just like, oh, you're the such and such people, and you come from the this and this. I know, I've had your food before, and I
Yeah.
know how you tend to operate, and so on. And so it's just, yeah, it's a really great way to sort of show how what it would be like 1,000 years after alien civilizations have met each other and have been interacting with each other in this way that feels very natural, much more like Star Wars
Yeah.
species,
And
right, than Star Trek.
there's just certain world building details, like recognizing different life forms are going to have different immune systems due to the
Yeah.
evolution of their worlds. And instead of doing 2 pages of exposition on it, it's just like, nope, you're going to get tortured by that decontamination chamber. And it's just like a fact of life. And I love when they create worlds by how it impacts the characters versus pages and pages of exposition.
Yeah.
And that's where she really shines, is her books are shorter, which makes me sad, but the stories are dumping you straight into a new reality, which I really enjoy.
Yeah, so it feels much less like I'm almost finished the book now, and I'm like, so when does the
Mhm.
story start? right? Because it's more like you're just immersed in this
You're just
really interesting
traveling with
culture.
them.
You're traveling with these people,
Yeah.
and sort of seeing just how they live. And yeah, their job is to punch holes in the with wormhole drives to blah blah. But mostly they're just exploring. They're interacting with this really rich environment, and I'm really enjoying that. So thank you for that recommendation. Well, we've reached the end of our hour, and so
And
now
it has been books and TV time with
books and TV
Fraser
time.
and Pamela.
Yeah, yeah, yeah. So hopefully everyone's got a few new things that they can watch. And then we will see all of you next week on Pamela's new computer and back at the home office. So we'll see you
It's
then.
true.
All right.
All right.
Thanks everybody,
Bye,
and
everyone.
we'll see you next week.
I think my country requires light and fluffy more than yours does at the moment.